From theheart.org, Medscape Cardiology. This is the Bob Harrington Show. Dr. Robert Harrington is the Arthur L. Professor and Chair of Medicine at Stanford University. This podcast is intended for healthcare professionals only. Any views expressed are the presenter's own and do not necessarily reflect the views of WebMD or Medscape.
Hi, this is Bob Harrington from Stanford University here on Medscape Cardiology and theheart.org. Over the last several years, I've had the pleasure in December of doing a yearly wrap-up with my good friend and colleague, Dr. Mike Gibson from Boston. In these segments, what we'd like to do is cover the landscape of cardiology. What are some of the trends? What are some of the things that Mike and I are talking about with our broader circle of colleagues that really caught our attention in the past year? This year, I thought we'd do topics. And the topics will run the gamut from what I'll call high-level policy issues to some specific clinical trial observations. And Mike and I will, in our usual way, go back and forth. With that, let me introduce my good friend and colleague. Dr. Mike Gibson is an interventional cardiologist at the Beth Israel Deaconess in Boston. He's also a professor of medicine at the Harvard Medical School, and he is the CEO of the Baim Institute, a not-for-profit academic research organization. Mike, thanks for joining us here on theheart.org.
Must be December. You and I are back at it.
Must be December. The Bob and Mike show goes again. Mike, let's go sort of what I'll call big, broad topics and then maybe filter down. And the first one I want to talk about in 2022, live meetings. They're back. We went to ACC, we went to ESC, we went to AHA, and then there was a lot of, smaller meetings in between. You cover a lot of the meetings from a news perspective. Give me your observations.
Well, we're back and it's great. I think the societies had done a great job of this whole virtual thing. I mean, it was amazing. People around the world could get on, watch what was going on, and participate in some kind of way where they could get the information. They got the data, but meetings are about more than data. They're about relationships. We practice evidence-based medicine, but we also practice a relationship-based medicine. And no matter what business you're in the people business, 70 to 90% of communication isn't the words, it's the body language. And when you do things virtually, you lose the ability to kind of connect and have that trust that develops from those kind of more intimate face-to-face connections. A lot of the meetings happen outside the rooms. And that's why it's so important to go to meetings. It's the hallway conversation that's almost as important as what's said at the podium. There's what's said at the podium, but then everyone's walking around trying to say, what did you think? They're looking for the digestion of that context. So I think it's been great. The meetings are smaller, but I'm running into all the people I really want to see. I do think they could maybe downsize the venues a little bit so the density is better. Sometimes when you have a great big convention center and there's just not that bumping into each other, it doesn't feel as hot or as exciting. But the best thing is being able to see my friends. Going up to you, Bob, give me a big hug. Can't do that online.
No, and I agree with you. The networking, how many times do you say, hey, Mike, there's this person I want you to meet, and I introduce you to somebody who ends up working with you, or you introduce me to somebody who ends up being a fellow here in the next couple of years. And so I do think that those sorts of interactions are critically important. And then, as you and I always talk about, there's the late at night, hey, I got this idea conversation where literally in the morning over a cup of coffee, in the evening over a beer, you can sketch out, this is a grant we want to put in together. This is a proposal we want to pitch to somebody. Those things only take place in that sort of intimacy. At the same time, wow, to be able to share the education with people for whatever reason, either don't want to or can't go to a live meeting, they can still get the education. And I agree with you, the societies and the other organizations have done a great job. One thing, Mike, I want to comment on, because you just finished, by the way, a very large clinical trial that enrolled a lot of its patients during COVID. I mean, one of the things that amazed me at the three big meetings in cardiology, ACC, ESC, the late-breaking clinical trials didn't stop. I mean, work was still getting done. You want to comment a little bit?
Yeah, it's dumbfounding. I mean, we got through COVID, we got through some unrest and war. Amazingly, the people in Ukraine are better able to follow their patients up than some of the US investigators. But it is a testament to, I think, the dedication to people around the world to continue to get the job done. On the other hand, Bob, I have to say, we are going to have the walking wounded after all this. I think a lot of sites closed down. They made it through some of these trials, but then they closed down. So we're going to have to go through a rebuilding phase. It's really a testament to everyone we work with that they got the job done.
Yeah, no, well said. And I do think a lot of sites did suffer, and research nurses moved off to clinical domain because there was a need at their institution. Or they just, were exhausted trying to do everything they were doing. And I do agree with you. I think there's going to be a rebooting of research, not just in the United States, but around the globe, to see if we can continue to do this better. And I do agree with you. I mean, the cardiovascular research community is amazing with their dedication to really wanting to answer questions.
Well, they flipped over to doing COVID trials too.
That brings me to my next one, which is COVID. We're certainly not done with the pandemic. The vaccines have made a big difference. The antivirals, the monoclonal antibodies have made a big difference. But we lost a lot of people in the United States, and we're not done yet. I mean, there's still people dying every day. Our own hospital still has, a number of COVID patients in the hospital this morning. I suspect yours is the same. Let's talk about two things, Mike. Maybe lessons learned in the research realm, and then I want to talk a little bit about cardiovascular issues post-COVID.
Yeah, I think we learned a lot about ourselves. One of the strengths of the United States and Americans is we are fiercely independent. One of the weaknesses of the United States is we are fiercely independent. What happened was we had a lot of well-intentioned people trying to answer the same question in 20 different ways. And, the UK kind of got it right. They got together. They had a series of well-organized studies that showed the path forward with a few therapies like steroids. We did kind of get our act together in April of 2020. Different agencies, the NIH, the FDA, CDC, all came together and said, "Look, we got to get organized. We have to identify what we think some of the best shots on goal are. We have to create some master trial protocols so everyone's doing things the same way, and we have to, develop some networks." That was successful. The lessons weren't all positive trials. And that's okay. That's important. We learned some things didn't work. We learned, that therapeutic doses of heparin were no better than prophylactic doses. We learned that adding antiplatelets in didn't help at all. We learned that things like ivermectin didn't work. And we learned that a lot of these new antibodies or combinations of monoclonal antibodies really didn't improve care either. It's a little bit like you're saying in Silicon Valley, fail fast. It's important in trials to fail fast too, to discard, therapies that aren't going to work so that we can go assess some that are going to work. So one of the most important enduring lessons is getting organized, getting these kind of master protocols together so that we can redo this again in the future when the next pandemic happens.
There were networks that have existed that were not designed for infectious disease pandemics, like the CT Surgical Network, that turned their attention to doing COVID studies. And guess what? They did it really well.
Yeah.
Because they were an organized group of investigators with supported infrastructure that then did really well. I love your comment on master protocols. I also like your comment, Mike, on failing fast, is that all of these studies that came out of NIH had built into them very aggressive early interim analyses to discard the ones that weren't likely to be working. And you're absolutely right. Sometimes knowing what doesn't work is as important as knowing what works. The final thing I'll say from a US perspective, that I do think we are uniquely positioned because of the type of investigators work with NIH. We haven't even seen yet all the mechanistic work that's going to emerge, all the biologic insights that are going to be made. So, I think, hey, more to come about trying to understand this disease and our biologic response to it.
Yeah, and we have a lot of battles to fight. I mean, we have a lot of long COVID out there.
Let's switch to long COVID, Mike, and post-acute syndromes. On this show, I have interviewed several people to talk about the cardiovascular implications of having had COVID infection. The analysis that came out of the VA in the spring that we talked about on this podcast pointed out that there was an increased risk of cardiovascular diseases. Rob Califf, our mutual friend, who's the FDA commissioner, has called this the coming tsunami of the common chronic diseases. What are you thinking about as we think about the world post-COVID?
Yeah, I read your group's study with interest, and surely COVID, is associated with long-term outcomes. I think we have to be very careful in understanding the causality there. The people who developed COVID and the people who developed the worst COVID cases tend to be those people at high risk. And, I think we've got to be very, very careful in adjusting for comorbidities and frailty and everything else, so we can truly attribute just how much of all that badness is attributed to COVID. I'm sure there is some there. There's good reasons to think some is there because of all the endotheliitis and damage to those, lining of your vessels and, the virus infiltrating your myocardium, et cetera. A lot of good reasons why we're going to see the tsunami of long-term outcomes. But I'm most worried about some of the cognitive effects and the long-term sequelae there.
Well, I'll put a pitch in that the NIH has a long-term post-COVID study that's beginning. It's a cohort study to begin with, but there's going to be randomized trials built off of that called Recover. Here at Stanford, we are a site, and I'm proud to say that I am a research participant, that I have signed up and have had my first visit post-COVID to participate in the collection of information about what does happen to us over the course of the years ahead. So I'm a longtime researcher, as you know, and I'm a research participant. So, to my colleagues out there, please do look up Recover and see if you can refer colleagues, friends, family, or yourself.
I was a member of the HERO study. So yes, it's important to not just be a researcher, but to be a patient and to, see what patients go through and what it's like to do all these surveys and stuff.
I will say that in my first visit, I'm sitting there getting my blood drawn, and I look at the number of tubes and I said, are you going to take all of that from me? And I'm a pretty knowledgeable researcher. So it made me think from a patient perspective, lining up 15 tubes to say, yep, that's all coming from you, might be a way that we can think about how we communicate that information.
Yes.
Mike, let's go to something that you know well, the whole world of wearables. You've been involved in a number of these studies. We here at Stanford have been involved with some of these studies. Boy, COVID was another time where telemedicine, wearable information, monitoring at home all helped us really accelerate. Do you remain bullish on the use of wearables and other digital devices for collection of information in the years ahead?
I do remain bullish. I think we're going to learn a lot. As you say, we have terabytes of information about each of these patients in some of our trials. When you put it all together, we then have petabytes of information that you can't say, here, take the database. You can't transfer the database. It has to live in the cloud. And it's fascinating to talk about, how you analyze the data, who has access to the data. So lots coming down the pike. When you monitor someone 24 hours a day, you're going to find things, but how much abnormal signal constitutes disease? How much AFib do you have to say you really have AFib? And particularly when it comes to deciding if someone needs a therapy that has some risk, like bleeding. So we have a lot to learn, in terms of how much disease warrants treatment. That's going to be the next frontier. We also don't want to create the worried well. We don't want to medicalize, every extra skipped heartbeat. So we're trying to find the happy medium there.
Yeah, a lot of lessons sort of about what I'll call the operational engagement, how you find people, how you get them engaged, how you get them to keep sharing their information, and then a lot to learn about what to do with that information.
Right. Well, I have to say though, I thought enrolling people over 65 into a virtual trial, I thought these people just aren't going to keep using the app. Continue to use the app 80 to 90% of the time. Months later, now maybe they didn't have anything to do at home, except use the app during COVID. But what we are finding, the positive news is that they're remaining engaged, which we are very surprised by.
And the studies we've done here, you're finding it's not just, as you say, the worried well, it's people with a history of coronary disease, with a history of hypertension, with a history of ischemic heart disease, that are signing up and that want to learn about their health and what might we learn from, these devices that we're all wearing. Mike, that brings me to the next question. And again, you've been doing this in your research group. You're talking about this huge amount of data. And what interests me is that it's also very disparate types of data. It's EHR data, it's actual images, it's wearable physiologic signals, it's environmental data. Some of the new tools, which are really old tools, but now being able to be applied because of things like the cloud, artificial intelligence, machine learning, neural networks. You can't pick up a journal right now and not see a paper where somebody has used one of these computational methods to gain some insights into a topic. Now, some of that, as you and I know, is, well, did you really need it for that? But some of it is really pretty clever, pretty creative.
Yeah, my favorite in that regard is the Mayo Clinic algorithm that can look at the EKG and determine if you're a man or a woman. I'm not sure we needed AI for that, but one of the things we published last year, bringing together wearables with AI, as an example, using a single lead, being able to diagnose a STEMI, that's kind of really cool, 24-hour day monitoring, without a trigger, and you can detect a heart attack. That's kind of cool. On the other hand, we have to be careful. It's a black box, and it's often overtrained on the training data set. Last week, we learned that something derived from all men in the VA system, well, it doesn't do that well when it comes to women. So we have got to make sure that the training will fit the general population. One of my favorite examples, though, in the imaging world is, an algorithm that detected your prognosis, or, determined your prognosis based upon the melanoma image. When you look in the black box, it was just detecting a ruler. If you had a ruler there, your prognosis was very poor. Of course, the ruler meant it was bigger. It wasn't anything to do with the serpiginous border. We've got to make sure we're looking at the black box. I think there's a lot of hope there. I'm not sure it's as good as the hype that's out there. I do think the progress is mostly being made in imaging, which is great. I don't think the imaging will replace people. I think it will supplement our human readers. And I have done research over on the decision-making side. Yeah, AI machine learning is a little bit better than logistic regression, but it doesn't really hit it out of the park. And we've got to be cognizant of that. And what we're working right now is on the fact that rather than predict a year down the road what's going to happen, but it's a little bit like the weather, I think we're going to do better with iterative looks. Well, you haven't bled after 3 months. You're a different patient now. You declared yourself a non-bleeder on your bleeding stress test. Let's now look forward to iterate and make that prediction again. So I think you're going to see an evolution in how we use these tools, and more of an iterative approach as well. But I think the future is exciting.
Yeah, and I agree with you around some of the early wins, if we will, around imaging. I mean, there's been a couple of things that have caught my attention. One is from your colleague in Boston, Callum McRae, who's done some really interesting work working with Shinichi Goto, a fellow who's come from Japan. You and I know his dad quite well as a clinical trialist. Done some really interesting work about how you can utilize imaging data sets and reconstruct information about more limited imaging so that you can extend those observations to that limited image. So the example here is that you get a lesser quality of image from someplace, maybe without well-trained echo text, for example, and using machine learning and other data sets, you can actually help almost reconstruct the information that you might have gotten if you had had a more full echo. Boy, start to think about the opportunities for that. I do agree with you, Mike. I think we need to test all of this stuff just because it uses artificial intelligence, machine learning, doesn't mean that you can avoid the need for understanding it in the use, say, for example, of clinical trials.
But I think it could really help in rural areas where you don't have as many healthcare providers. For instance, So look at the pull through from the Mayo chain. They can detect LVH on the EKG. AI does. Then that's a trigger for, hey, you need an echo. And then, you have a little echo probe that the nurse can use that says turn to the left, up, down, and then it interprets it using AI.
And I loved how you said it. One of our radiologists here, I always paraphrase when he's asked, will AI replace radiologists? And we could say replace cardiologists. His answer is no, but radiologists / cardiologists who use AI will replace those who don't.
Correct. Yeah.
Mike, let's now move to randomized clinical trials coming from China, not as a participant in much larger trials, but the entire trial, some very large trials, some very good ones. I mean, there was a terrific one that Greg Stone presented on bivalirudin, which looked to be, at least from the presentation, exceedingly well done. And then there was one that my colleague Ken Mahaffey gave the commentary on, which was a dietary supplement as an adjunct to ST elevation MI. Forget the topics that they studied, Mike. Just comment broadly as a trialist. Wow. If China can really do some of these studies with their organized workforce and their population, they can make major contributions to the rest of the globe.
Absolutely. In anticipation of our call today, I got on clinicaltrials.gov. I typed in STEMI and I typed in the search term of China. Out of the 740 STEMI studies that are ongoing worldwide right now, 120 are being done in China. How many do you think are being done in the US?
Less than 100.
78.
Yeah.
So, they are really getting the act together, like we said earlier, right? Getting organized.
Yeah.
Matt Herper on STAT said, the single biggest risk in upcoming biomedical development isn't, having new technologies. It's getting organized and doing randomized trials to assess the technologies. This is an issue of execution. And if they're able to execute, which it looks like they can do great things. The other thing they're doing is, they're taking a lot of shots on goal. They're assessing things that we would have discarded in the US, alternate therapies that we may have discounted. So I've always been worried that we're spending $1.2 billion to assess drugs. What if we could do it much more quickly and assess many more targets? That would be a better way for the ecosystem to find new therapies.
Mike, as always, this has been a really fun discussion. My guest today has been my good friend and colleague, Mike Gibson from Boston, interventional cardiology professor at Harvard, and the CEO of the Bain Institute, a not-for-profit academic research organization. Mike, thanks for joining me on Medscape Cardiology.